The opposite of experimental probability is theoretical probability. Theoretical is what should happen in theory, not what actually happened in an experiment. So we're going to talk about theoretical probability, how to figure it out, but first we have to define this thing, equally likely. And it's exactly what it sounds like. When the outcomes in a sample space of an experiment have the same chance of occurring, the outcomes are said to be equally likely. So if I roll a number dice, there's 6 options on there, and all of them are equally as likely. You're not going to get a 6 more than a 1, theoretically. So the theoretical probability of an event is the ratio, or a division problem, of the number of ways the event can occur to the total number of equally alike outcomes. Theoretical probability is based on what is possible, what should happen in theory, but not what actually does occur. So here's our new formula, but it's basically the same as experimental. It's the number of ways that the event can occur divided by the number of outcomes. So let's do an example or two. An experiment consists of rolling a number cube. Find the theoretical probability of each outcome. So the first one is the probability of rolling a 3. So on a 6-sided dice, there's only 1 3 on there, divided by the total number, which is 6. So there's a 1/6 theoretical probability of rolling a 3. Now rolling a number greater than 3, that includes the numbers 4, 5, and 6. So that can happen 3 different ways out of the 6 sides total. And we would reduce that to 1/2. There's a 1/2 chance that if you roll a number cube, you will get something greater than 3. An odd number. There are a few odd numbers. You could roll a 1, a 3, or a 5. So exactly like the last one, there's 3 ways that could happen out of the 6 total sides. So there's a 1/2 chance of you rolling an odd. Rolling a 7. There is not a 7 on the dice. So that means that it doesn't matter how many times I roll it, I am not going to get a 7. So the probability of rolling a 7 is 0. Never going to happen. When we figure out probabilities, it's also important to recognize the complement of an event. So the complement of an event is all the outcomes in the sample space that are not included in the original event. So if we go back to this problem, the probability of rolling a 3, the complement would be the probability of not rolling a 3. So rolling a 1, a 2, 4, 5, or 6. So here's another formula. The probability of an event plus the probability of the complement, like everything else, has to give you 1. And that's because all of our probabilities have to total 100%. So on a dice, we have those 6 different options. The probability of rolling a 3 is 1 out of 6. And the probability of rolling everything else is 5 out of 6. And that adds up to 1. The total number of options. So the example down there, basically the same thing that I just did. What is the probability of rolling a 5 on a number cube? Well, there's only 1 5 on there. So it's 1 out of 6 chances. And what's the probability of not rolling a 5 on a number cube? Well, you have 5 other options out of the 6 total. So here's the type of problem that you're going to get. The first 2 are really too easy. So let's say that a jar has green, blue, purple, and white marbles. Here are the probabilities of choosing each color. Probability of choosing green is 0.2 or 20%. Probability of blue is 0.3 or 30%. And purple is 0.1 or 10%. What is the probability of choosing white? Well, we know that your jar only has green, blue, purple, and white marbles in it. So that means that the probability of picking a green one plus the probability of picking a blue one plus the probability of picking a purple one plus the probability of picking a white one has to add up to 1. So we have most of these numbers. We have 0.2 plus 0.3 plus 0.1. We need to figure out what this guy is here that would have everything add up to 1. So if you, sorry, this is a 3. If you add up 0.2 plus 0.3 plus 0.1, you end up with 0.6. So that means that the leftover stuff, or whatever else we need to make 1, is 0.4. So the probability of choosing a white one is 40%. There's way more white ones than there is green, blue, or purple. Odds are very different than probability, and they get mixed up all the time in the real world when we say those two words. Odds aren't divided by the total. Odds aren't even a fraction. Odds are written as a ratio, usually with a semicolon. Odds compare the favorable outcomes to the unfavorable outcomes. So there's never a total in here. You have favorable outcomes, semicolon, unfavorable outcomes. So when reporting the odds in favor of an event, the favorable outcomes are reported first. So favorable, unfavorable. When reporting the odds against it, like what are the odds against you getting 100% on the next test? You put the unfavorable ones first, and then the favorable ones. So they've said that word a million times. It's starting to sound weird. Let's actually do an example. What are the odds in favor of rolling a 3 on a number cube? So the number of favorable outcomes would be rolling a 3 to not rolling a 3. And remember, the total is not going to be a part of this anywhere. So how many 3s are there on a dice? Only 1. And then not a 3, there's 5 other options. So the odds in favor of rolling a 3 are 1 to 5. The total can be found if you add those two things up. There's 1 3 on there and 5 other things, and those added up will give you the 6-sided number cube. Next one, what are the odds against rolling a number less than 3? So against less than 3. And then our favorable outcomes will be less than 3. So how many numbers are less than 3? We have 2 and 1. So we have 2 numbers that are less than 3. And that means against rolling them, or not numbers less than 3, are 3, 4, 5, and 6. So there's 4 different options. So the odds against rolling a number less than 3 are 4 to 2. Probabilities are reported as part-to-whole ratios, comparing the favorable outcomes to all the possible outcomes. Odds are reported as a part-to-part ratio, comparing the favorable outcomes to the unfavorable outcomes. Underline this, start, do something. People get these confused all the time. You need to remember which one's which, and then also be able to figure out which one you're looking for when the problem asks you. So an example, now that we know everything and we're going to put it all together. A bag contains 3 blue, 2 red, and 5 green marbles. What is the probability of choosing a red marble? So if we are finding probability, we know we need to take the number of reds and divide it by the total. So I have 2 reds in the bag, and the total is 3 plus 2 plus 5, or 10. And then we could simplify this. We could write it as 20%. You could write it as 1/5. There's a 1/5 chance of choosing a red marble. So the next question, almost the same thing. It says, what are the odds in favor of choosing a red marble? So odds in favor of choosing a red are the number of reds that I can take out, and then the number of not reds, not the total. So the number of red ones is still 2, but the number of not red ones are just 3 and 5, or 8. So the odds in favor of choosing red are 2 to 8. And again, you can find the total of 10 if you add those guys up. So the next one, what are the odds against choosing a red marble? So this one's exactly the opposite as the one before it. We want to not choose a red marble. So the number of ways that we can not choose a red marble is 8. And then the number of red marbles in there is still only 2. Make sure you know the difference between probabilities and odds. Have a good night.